Today's video will be all about Hess Law. What is Hess Law? Hess Law, or Hess Law of Constant Heat Summation, is a rule that was first enunciated by the Swiss-born chemist named Germain Henry Hess. This law states that, regardless of multiple stages or steps of a reaction, the total enthalpy change for the reaction is the sum of all changes. Which means that, in accordance to the law of conservation of energy that states that energy cannot be created nor destroyed, the energy of a chemical reaction came from the energy from the previous reaction. Hess law is exemplified by the calculation of the heat of formation of carbon dioxide from its elements carbon and oxygen. This reaction is represented by Cc plus O2G to form CO2G. In the equation, C and G denotes crystalline and gaseous respectively, and delta H degree is the heat of formation. Heat of formation is defined as the enthalpy change for the formation of 1 mole of substance from its constituent elements in their standard state. In other words, enthalpy is the amount of heat absorbed or evolved in a chemical reaction. In accordance with Hess law, the heat of formation of carbon dioxide is the same whether it occurs in one reaction as represented by the equation above or in 2 steps as represented by the equations given below. And with that being said, using Hess law, we could actually calculate the amount of enthalpy of the reaction from the previous reaction, which is called as intermediate reaction. And in doing so, or in solving Hess law problems, we should follow these guidelines. To come up with the target equation, we should manipulate the intermediate reactions. In manipulating intermediate equation or reaction, we could reverse or multiply it by a constant. And if the reaction is reversed, the sign of the change in enthalpy will also change. It will also be reversed from negative to positive and vice versa. For example, the reaction of carbon and oxygen gas to form carbon dioxide with the enthalpy change of negative 393.5 kJ per mole. If you have to reverse the reaction, all compounds on the reactant side will be on the product side and all the products will be on the reactant side. So we have carbon dioxide gas to produce carbon and oxygen gas, and the enthalpy change has been changed from negative to positive. And if a reaction is multiplied by a constant, the change in enthalpy is changed by the same constant. So for example, if you have to multiply all the reactants and the products by 3, the enthalpy change will also be multiplied by 3. If you have to make it half, so we have to divide it by 2. For example, we have to find the enthalpy change of hydrogenation of ethene with the chemical equation of C2H4 plus H2 to form C2H6 from the intermediate reactions below. From that problem, we will consider C2H4 plus H2 to form C2H6 as our target reaction, wherein we are going to determine the enthalpy change of it from the intermediate reactions of C2H4 plus 3O2 to form 2CO2 plus H2O with the enthalpy change of negative 1411.1 kJ per mole. The second intermediate reaction of H2 plus 0.5 O2 or 1/2 O2 to form H2O with the enthalpy change of negative 285.8 kJ per mole, and C2H6 plus 3.5 O2 to form 2CO2 plus 3H2O with the enthalpy change of negative 1560.7 kJ per mole. So, how are we going to manipulate the intermediate reactions? So, pwede natin siyang i-reverse, i-retain, or i-multiply to a certain number na ang magiging resulta ay yung certain amount ng mole ng bawat reactant or product doon sa ating target equation. Okay, so kung mapapansin nyo, sa reactant ng target equation, matatagpuan natin ang C2H4. At matatagpuan din natin to sa reactant ng first intermediate reaction. So, ang gagawin natin is i-retain yung first equation. Second equation. So, matatagpuan natin ang H2 on the reactant side, which is nasa reactant side siya sa ating target equation. So, ang gagawin natin is i-retain din natin ang second intermediate reaction. And on the third reaction, we have C2H6 on the reactant side, pero sa target equation ay nasa product side siya. So, ang gagawin natin is i-reverse natin yung third intermediate reaction. So, now, i-retain natin ang dapat i-retain at i-reverse ang dapat i-reverse na reaction. So, pag ni-retain natin, kukopyahin lang natin yung mga intermediate reactions na i-retain together with their enthalpy. And then, pag ni-reverse natin, magiging reactant lahat ng product at yung product ay lahat ay magiging reactant and the enthalpy will be reversed from negative magiging positively charged. So, this is what will happen. So, 2CO2 will be on the reactant, 3H2O, and then C2H6 and 3.5O2 will be on the product side. And then, yung sign from negative, yung enthalpy niya ay naging 1,560.7 kilojoule mole per mole positive. And then, after that, pagsasama-samahin natin lahat ng substance on the reactant side and the product side. So, how are we going to do that? So, we will add C2H4 plus 3O2 plus H2 plus 0.5O2 plus 2CO2 plus 3H2O on the reactant side. And yung product, 2CO2 plus 2H2O plus another H2O plus C2H6 plus 3.5O2. And we will come up with this equation. So, we have C2H4 plus H2 plus 2CO2 plus 3.5O2 mula sa 3CO2 plus 0.5O2 plus 3H2O to form 2CO2 plus 3H2O plus C2H6 plus 3.5O2. And for their enthalpies, i-add din natin sila lahat. So, we have negative 1,411.1 kilojoule per mole plus negative 285.8 kilojoule per mole plus 1,560.7 kilojoule per mole. And the next step, we have to simplify this equation. So, how are we going to simplify it? So, ang gagawin lang natin, lahat ng mga substance or compound na parehas meron sa reactant at product side is isusubtract natin. So, if we have here 2CO2 on the reactant side and we also have it on the product side. So, ang gagawin lang natin is subtract natin sila. So, 2 minus 2. So, makakancel silang dalawa. And then, aside from that, we also have 3.5O2 on the reactant side, which is, we also have 3.5O2 on the product side. So, ika-cancel lang din natin sila. And then, we have 3H2O on the reactant side minus 3H2O on the product side. So, makakancel din sila. And then, kung ano yung matira, yun yung magiging final equation. So, we have C2H4 plus H2 to form C2H6, which is the same on our target equation. And then, i-add lang natin yung mga enthalpies. The enthalpy of the reaction will be negative 136.2 kilojoule per mole. And this will be our final answer. Okay, so we have the enthalpy of the reaction is equal to negative 136.2 kilojoule per mole. Okay, so let's have another example. You have to calculate the enthalpy of the reaction for the synthesis of hydrogen chloride gas from the following data. So we have given the target equation and we have the intermediate equations together with their enthalpies. Okay, so from that problem, the target equation will be H2 plus Cl2 to form 2HCl, and we have to identify its enthalpy. And the intermediate reactions are NH3 plus HCl to form NH4Cl with the enthalpy of negative 176.0 kilojoule And second intermediate equation, N2 plus 3H2 to form 2NH3 with the enthalpy of negative 92.22 kilojoule. And the third intermediate equation is N2 plus 4H2 plus Cl2 to form 2NH4Cl with the enthalpy of negative 628.86 kilojoule. So first step, we have to manipulate the intermediate reaction. Alamin natin alin ang i-retain, i-reverse, or i-multiply to a certain number. So as you can see sa target equation natin, nasa reactant si H2. So saang equation kaya matatagpuan ang H2? So based on the intermediate equation, meron siya sa second and the third intermediate equation. So what are we going to do kapag parehas na meron sila? So kung mapapansin natin, isa lang ang mole ng H2 na kailangan natin for the target equation. And as you can see on the second and the third, we have 3 plus 4, we have 7 moles of H2. So what are we going to do para isa lang ang magiging H2 na meron sa reactant side? So you have to analyze and maisip natin na kapag halimbawa si 4H2 ay nasa reactant at si 3H2 ay nasa product, pag sinubtract natin para sa mamaya na process is may matitirang isang H2 sa reactant. So ang gagawin natin, si second equation ng ating i-reverse at yung third equation ang ating i-retain. And then next, we have Cl2. So, saan ba merong Cl2 sa ating intermediate equation? So, it is located on the third intermediate equation. So, since i-retain nga natin siya, at tama lang na i-retain natin siya para manatiling nasa reactant si Cl2. Okay? So, next, 2HCl. So, where can we find 2HCl? So, it is located on the first intermediate equation. But as you can see, it is located on the reactant side. So, the one that we're going to do is to reverse the first equation. Aside from that, as you can see, we have 2 moles of HCl na kailangan. So, aside from reversing this equation, we have to multiply the whole equation by 2. Okay? So, now, i-reverse. Ito times 2 ang first equation. I-reverse ang second equation at i-retain ang third equation. So, let's see. Okay. So, for the first equation, we have to reverse and multiply it by 2. So, anong gagawin natin? So, from NH3 plus HCl to form NH4Cl, magiging 2NH4 because we have to reverse and multiply it by 2. Cl to form 2NH3 plus 2HCl. So, since na-reverse at pinultiply natin by 2 ang ating equation, we have to do it also to the enthalpy. So, i-multiply natin by 2 ang 176 at i-reverse natin ang kanyang sign. So, magiging positive 352.0 kilojoule. And then, second equation, we have to reverse it. So, i-reverse lang natin lahat ng reactant magiging product and vice versa. So, we have 2NH3 to form N2 plus 3H2. And since ni-reverse natin from negative, naging positive ang enthalpy. And then last, we have to retain. So, kakopy lang natin ang kanyang equation together with the enthalpy, which is negative 628.86 kilojoules. And then next step is to combine all the reactants and all the products. Okay? And then we have 2NH4Cl plus 2NH3 plus N2 plus 4H2 plus Cl2 to form 2NH3 plus 2HCl plus N2 plus 3H2 plus 2NH4Cl. And then, ganun din ang gagawin natin sa kanilang enthalpy. Pagsasama-samahin natin or i-add natin. So, we have 352.0 kilojoule plus 92.22 kilojoule plus negative 628.86 kilojoule. And then, after that, we are going to simplify this equation. So, kagaya nga ng sinabi ko kanina, kapag parehas na meron sa reactant at sa product, isa-subtract natin. So, kung walang matitira or magiging 0, maka-cancel silang dalawa. So, for 2NH4Cl, meron ba sa product side? So, meron. Cancel. So, we have 2 moles each. And then, 2NH3, meron sa reactant, meron sa product, so cancel. And then, N2, meron sa reactant, meron sa product. And then, 4H2 minus 3H2, may matitira kang isang H2. And then, matitira mo is plus Cl2. And then, we also have 2HCl. Okay? So, kung ano yung matira, yun yung ilalagay natin sa ating final equation, which is we have 1 mole of H2 plus Cl2 to form 2HCl. And then, you will add the enthalpies. The sum will be negative 184.64 kilojoule, and that is the final answer. So, looking at the target equation and your final answer, are they the same? So, yes. So, that is the correct answer. Now, I want you to try this practice problem. What is the value of the enthalpy for the following reaction? So, the target equation will be CCS2 plus 3O2 to form CO2 plus 2SO2. Please pause on this part. Okay, so we have retained the first intermediate reaction. We have doubled the second intermediate reaction and reversed the third intermediate reaction. Then add all the substances on the reactant and the product side. Simplify and you will get also the sum of their enthalpies, which is equal to negative 1075 kilojoule. And that is the final answer. And that's it for the Hess Law. Thank you for watching.